close the door. Is it open? Okay. What time is it? It's 2:05. Okay, so welcome to the beginner technical track. I think this track will just cover some beginnings. For my presentation, it's 6-wheel drive with geckos. This is mainly for hardware, so just get right into it. Great, so my name is Derek He. This is my 12th year in FIRST, and this is my 6th year in FTC, so I've been doing this for a long time. And on 8565, I'm part of the hardware team. I'm also part of the driver team, and I was the driver team captain for 8565 at the World Championship. And outside of robotics, I play the cello. So going through this agenda, first I'll just detail why this project, why I decided to go with it, what inspired it. I'll then move on to the design, all the way from the CAD to the specific parts I used, and then the build process of actually doing it, and of course, we'll then move on to the results and the conclusions. Okay, so of course, everyone knows what 6-wheel drive is, but 6-wheel drive with geckos. So as we all know, Gecko wheels are not really commonly used for chassis. You often see them used as an intake wheel because of their texture and their grip. So the reason why I decided to go with this project is because I want to try something new. So just try a chassis with Gecko wheels. And I want to experiment with the grip that could possibly provide, along with the viability of actually potentially using a Gecko wheel chassis in actual competition, right? You see most chassis that use grip wheels. Past few seasons you see lots of Magnum wheel drives. So that's why I want to try something new. So starting off with the product design. So for every single build, I started that with CAD. So before I even started touching the parts or anything, I just got everything in CAD. So CAD, of course, it's like probably one of the most important steps in determining what you need to build, because not only it determines what parts you need, it also determines where you want to allocate the space on your design, right? So I'll just start going into my project. So I decided to go with 13.7 to 1 ratio from GoBuilder. They're like pretty fast motors. Also decided, if you look closely, you can see. So you can see that there's gears, pinion gears, 32th pinion gears, all 32th, and then pulley gears, 16th. So everything's in a 1-to-1 ratio. So what's special thing about this, you can look more closely, is that in a normal chassis, you can see that. So there's 4 motors on a chassis. Each motor is powering each individual wheel, right? So one motor will go to one wheel. For this design, 2 motors are powering the 2 sides. So essentially, each corner of the robot is getting the full power of two motors. So this is just a direct transmission of using 2 motors to power each side. It can give you a faster turning circle and more agile maneuverability. And then if you look more closely on like this shaft and the spacers, I'll just do that example. For this, you can see that there's no collars at the end, right? This is done by, I took 2 bearings and the flank bearing on the inside, and what I did was put spacers in between. So that eliminates the need for using collars on each side. And the one probably main benefit of this is that lots of the times the shaft collars, the set screw will get loose after lots of running matches, right? But by using spacers, it's physically limited. So there's no way any screws can get loose. So it just eliminates the possibility of a set screw getting loose. That's one thing you guys want to consider. And also, you can see that it's really compact. The axle's like barely sticking out the other end. So overall, this entire chassis design in CAD is just really compact. I decided to use like Rex shafts with like a little clip on the end. I think that's one of their newer, from GoBuilder, it's like one of their newer Rex shafts. But it's really compact. So with this base chassis, you can fit in a lot of subsystems. So I think this will work great as like a base chassis for you to mount other subsystems on. Yeah, so actually starting to build it. I already talked about both motors powering on both ends, and then just 4 motors, 6-wheel drive. And for belt tension, GoBuilder has this, like, if you don't know what size belt length you can get, there's on GoBuilder's website, they have like a belt length calculator for like you just use that calculator and you can determine what length you need. So I use 320 millimeters for the short side, I think 420 for the long side, and then I don't know if you can look closely, but there's like little belt idler here that just provides more tension on the belt so it doesn't become loose. And if you want to look close up, my project's right here, and I'll take questions at the end, by the way. So, right. So, one of the main obstacles I ran into while building this is actually with the Rex shafts and the Rex bearings itself. So GoBuilder has like D shafts. They also have Rex, which Rex is hex. So I'm not sure if this is like a GoBuilder manufacturer problem, but from what I experienced, all my parts were new, by the way, just straight out of the box. One of the main problems was that you can see on the picture, the Rex bearing would get stuck on the shaft quite often, right? Usually bearings just slide in, you just push it in and it just goes smoothly, maybe a little bit of force. But this one I actually had to use a hammer for almost 75% of all of them, 75% of all my bearings and shafts. Of course, you can still do it, right? I used a hammer, did the force, but I'm not sure. I probably would recommend GoBuilder D because I haven't experienced any problems similar to this, but you guys can try for yourselves for Rex. This is just a problem that I ran into. That was time consuming at first because I didn't know how to hammer it in. But once you figure out how to hammer in the first one, all the other ones just take like 2 minutes to do. So. Okay, and then of course I just built one side and the other side is just a mirror. So that was pretty simple. I just connected it using 4 face mounts, 2 GoBuilder U channels in the middle. This offers really sturdy mount connection at 2 points, and so the chassis just becomes really sturdy. And then just to mount the expansion hub and battery, I used 2 Rev expansion hub mounts. I used one of them for the battery and just zip tied the battery down. Realistically, if you're doing competition, you want to have more secure, so probably do something better than a zip tie, but just for the sake of keeping it secure. Okay, I'll do a live demo after. I think I'll go over the conclusions. So I can do a live demo now. So this is the actual chassis right here. So I'll just quickly run it. So this is the underside of it. Basically everything in real life. So I just programmed a basic teleop drive. So just arcade drive, but you can see that, right? The entire thing is really compact, right? You have all this space here to work with. You have all this space down here. And then the top of it, if I just move these expansion hub and the battery to the side, you have all the space open to use for all your other subsystems. So really, this design is really compact, and that's probably one of the main advantages of it. For a live demo, I think I'm not sure how I can drive it, but I'll try to keep it on the table. So the turning speed is really small, and it's quite fast. Maybe you guys can drive it later, I'm not sure. But basically, for conclusions, because it is Gecko wheels, and Gecko wheels are just so naturally grippy, this chassis has great traction on the field. I drove it on the field yesterday on FTC floor mat. It was great. That's why it also makes it really agile and fast. So it has great maneuverability, and probably moving on to how it's viable, if it's viable in a competition, because it's also Gecko wheels, and because it's so grippy, it attracts a lot of dust. And as we all know, FTC fields aren't the cleanest, especially during competitions, right? After tons of matches, lots of robots go on it. It's really easy to attract dust. So if the dust accumulates on the Gecko wheels, it loses grip pretty easily. So if you were to take this into a competition, you'll probably have to clean it before every single match, just to make sure, to maintain that the robot has its grip. I guess, alternative to this, you can just use grip wheels or Omni wheels as a replacement for the Gecko wheels. I think those would just work just fine. But Gecko wheels do offer superior traction. I think that's it, if anyone has any questions about it. Yes.
Will you be sharing the slides?
I'm not sure.
We're probably going to put the recorded presentations on YouTube. I don't know if we're going to share the copy of the slides.
That's good.
Yeah.
Okay. Yeah.
How does it do with weight as the weight of the robot increases?
Yeah. That's a great question because I have not tested that because I haven't. In the past, I'll speak from past reference. So in the past summer workshops we did, one summer workshop like a few years back. We did a ton of chassis, like 4-wheel drive, 6-wheel, 3-wheel drive, 2-wheel drive, everything, and we did weight tests with it, and a bunch of different tests, ramp tests, weight tests, turning tests, whatever. And 6-wheel drive, I think it was the best for the weight test, just because it was 6-wheel drive. 6-wheel drive is also was the best for turning. So I think to answer your question, like how does it deal with weight? Because it's a 6-wheel drive, I think it'll deal much better, not much better than 4-wheel drives. But 4-wheel drives are still do great under weight. As for Gecko Wheels, you can see that Gecko Wheels are squishy. So I chose to use I think 4-inch Gecko Wheels or 3-inch Gecko Wheels, so the clearance isn't that high. But if you were to use I guess bigger Gecko Wheels, Go Builder has like 96mm ones. I think it'll still do good on weight. Yeah. Any other questions? Yeah.
Why did you choose that size?
For the wheels?
Yeah.
So Go Builder has like 4 Gecko Wheel size. The one below this will be too small, and the one above it wasn't too big. But I just decided to go with this because it just keeps a low profile. Like it just leaves a lot of room on the top of the Go Builder U channels. You can see you have all this. If I were to move this hub to the side, you have all this space to work with, right? Compared to if you have like a bigger wheels, you'll have to probably mount it and probably have to keep it within the size. So it's just more compact. That's why I chose
And
this.
are you allowed to like modify the wheels to make them like less squishy so it can handle more weight?
For FTC game?
Yeah, like you know how there's spaces in
Yeah.
like the Gecko wheel. Are you allowed to stuff things in that so it's less
I don't.
squishy?
I don't know actually. Like go read the game manual. You could probably find it in game manual, the FTC game manual, if you're allowed to modify parts and stuff. But yeah.
I noticed that you all have from Technobots, you all have different projects. Is that something that you, as a team, you say, okay, everybody go off and build your own?
Yeah.
Or, oh, really? And so what makes it into the final bot that says, this is the bot that Technobots is going to use in the competition? Like you have one, he has one.
Okay, so I think I'll answer the first part, which is the summer project. So our summer project is basically like whatever you want to study, right?
Okay.
It's like whatever you do. So one year I did, if you guys are familiar with differential swerve, you might have saw the chassis. I did that 2 years ago, just because Gluten Free did it. I was like, well, that seems pretty cool. Why not try it? And did pretty well. But to determine what actually goes on the robot, I think our summer project's more for exploratory purposes, like whatever we're all passionate about. Like, it doesn't have to be necessarily viable in a competition, right? That's not part of the things that we're thinking about. It's just something that maybe it's possibly, but it's not necessarily. It doesn't have to be viable. It's just something that we want to try. I know next topic's like Quadrabot, like a spider bot. Like you wouldn't see that in a competition field.
Right.
Yeah. So. And I guess to answer the question of how we just determine what actually goes on our robot, that goes into another topic of just our design process and brainstorming and stuff. So that's just a whole other thing. But yeah, our summer tried mainly for whatever we want to research. Yeah. One more question.
You mentioned you tested 2-wheel, 3-wheel, 4-wheel.
Yes.
Did you try 5-wheel, 7-wheel, 8-wheel? Why stand with 6-wheel?
Honestly, I would have to pull up the records from our workshop. I don't think we did 5-wheel. I mean, if you had an odd number of wheels, I don't know. The reason we had 3-wheel is that 2 wheels and then one would do a horizontal axis, so it was like a Magnum wheel but with 3 motors. So I don't think we tested with 5 or 7 wheels.
Okay.
But yeah, to answer that question. Is that okay? Thank you. Oh, yeah.
I'm new to this, so
Yeah.
I'm assuming you have a coding portion work,
Yes.
and this is the mechanical design, right?
Yeah.
But when you do this mechanical design part of work, how would you predict that you will have some challenge in the future to code and control them?
Yeah, so for this, I mean, for my summer project, this was just a basic tele-up drive. So it's just basic arcade, basic tank drive. You could do that too. But if you were to do something like a MECDEM drive, if you don't code it the same way, I guess how you determine that, I'm not a programmer myself, but it does get more complex. I can pull up example like my differential swerve. That's completely different from this tele, because the two motors are, it's just a different thing, different concept completely. So it really depends on the chassis, but most chassis, it's quite simple. There's probably code out there because like so many teams do it. You can probably pull it off GitHub or something. So. Okay.
Thank you so much, Derek. So next we're gonna have Andrew. While he's setting up, has anyone not gotten a ticket from me yet?
Just connect that hub to it as well.
Yeah.
Sweatshirt is this. Is this your phone?
Melody?
Wait, can we sign in? I don't, or it locked. I don't know. I don't think it stopped. Okay. Are we gonna stop it?